Welcome. We have a question on Doppler effect. We have a submarine which is stationary, and then we have stationary there, meaning that the velocity of the submarine is 0. And moving up to the well, we find that the well has a velocity of 8 meters per second, moving towards the submarine. And then we're asked to define Doppler effect. So it's actually the change in frequency of the pitch of sound detected by a listener, because the sound source and the listener have different velocities relative to the medium of sound propagation. Propagation meaning the movement in that case. And then as it's moving towards, will it be higher? Yes, it will be higher. Reason, because it's coming towards a stationary source. So that is what we'll have to conclude, and then we'll be looking at the next question. So don't be scared to pause. You have to pause the video and go through the questions slowly. And then the other thing you're gonna look at, when a more object moves away, then it's gonna be lower frequency, and then when we have towards, it will be higher frequency. So the same with the reverse. And then we look at the situation here where we're supposed to calculate the velocity of the frequency of the listener. We use the generic equation V plus or minus VL divided by V plus or minus VS, which is velocity of the source, the velocity of listener VL, multiplied by the frequency of the source. And then we have to simplify that, because the plus or minus, we should make an option there which is going to be plus, because the velocity of the source is stationary. Okay, then we multiply that by frequency of source. We look at value of information. There we have the velocity of the sound in water to be 1435 plus 8, which is speed of the whale, divided by 1435, multiplied by, we look at the frequency of the sound and as detected by the source, that the frequency of the sound of source, multiplied by that, giving us 23,128.22 Hz. So that's 23,000 Hz. That is the frequency with which since it's the listener, with which the listener observes. And then coming up to the Doppler effect is find that you also regulate the stars, find out if they're moving away and so forth. We're using the rate light. We find that the wavelength there initially it was 688 and then detected on Earth as 653. So that means that is it moving near or further? So looking at the wavelength, because it has decreased, that is 653. So we're going to look at what is the equivalence in terms of the frequency. So you know that we have constant, which is frequency multiplied by the wavelength, and then we have wavelength, which is equals to constant divided by frequency, and that means also frequency is going to be constant divided by wavelength. So that means that we have constant divided by if it's divided by wavelength, then it's going to be frequency. So if it's constant divided by frequency, then that is wavelength, because constant is the product of the frequency and wavelength. So that is the wavelength there, who is going to be going closer. You see that it's C over frequency. So you have frequency there, which is constant divided by wavelength. So you want to see which one has more frequency. More frequency would mean you have more frequency. It means that you have more frequency means you're coming closer, and less frequency means more frequency means you're coming closer, less frequency means you're moving away. So you're dividing that by constant. Remember that constant, the speed of sound, that would be the one that we're given, which is we find that A is greater on the latest situation. So don't forget to subscribe. Thank you so much.